Here's a presentation and talk about any toolpaths in general. We're going to specifically talk about the 5-axis toolpaths. So as any toolpath I decide to do inside Mastercam, no matter what toolpath it is, 2D, 3D, drilling holes, I always ask my students, what do you want the toolpath to look like? Yes, I get the funny look of, well, I just want to go drill those holes, or I just want to profile around the outside of the part. Gets a little more involved when you're talking about a 3D or 3D or a 5-axis toolpath in the sense of that, well, I want to start at the top and I want to blanket down or quilt down the side of the part or morph down the side of the part. Maybe I want to slice my part up in Z and then just contour around it and step down in even sizes, even step downs. Mastercam has a series of toolpaths to be able to do this. You would have to pick the right pattern in the application to get the motion of the toolpath that you want to be correct. And then after you get the motion correct, then you would worry about how you want to control the axis of the tool, how you want to control the tool from shanking out or hitting or what you would like. Here's an example of a parallel toolpath in Mastercam. We'll hit the back plot button. It shows pretty well. As I go down inside the tool, I'll show the part translucent. Even in Mastercam introduced in 2019, we have the section view that I could actually see inside the part and do a cross section of the part to be able to see what's going on. As we all know in Mastercam, I could just pick a spot right here and in backplot and be able to see that this is a really good toolpath. The shank of the tool is avoiding, the ball nose, the cutting end of the tool goes all the way down to the edge of the part. And as I get up, as it comes out of the cavity shape, it actually zigzags around and gets out of the cavity shape. To be able to reproduce this tool in Mastercam, I would start off with a toolpaths parallel. Lollipop cutter, same tool that I have. There's my toolpath. Cut pattern. We're going to just use constant Z motion as I go all the way around. We'll have some pretty big step downs as we go down, just as a demonstration purposes. Not going to cut this part. And we'll spiral down the side of the part. Here's our cut tolerances right there. Tool axis control, for default, we'll leave it normal to the cut, and we'll get rid of all collision. This is where I start all the time when I generate 5-axis toolpaths. All I want to see is what motion I generate when I generate a toolpath. Do I like the way that Mastercam sliced up the tool and the motion of the toolpath? And then I'll worry about controlling the axis of the tool, and I'll worry about collision. And I did not select what I wanted to machine. So with a solid, we'll get rid of our section view. With a solid, I can grab a hold of one entity, hold the shift key down, and it picks the whole part if it's tangent. Looks like I have a little face right down here on the bottom that is not tangent. So I grabbed a hold of that geometry. There we go. And selection. And now we can spiral down to the bottom of the part. Takes a few seconds to generate this toolpath. Pretty quick. Toolpath looks really good. Look at my section view again. Toolpath looks really good, really clean. Motion comes back out of the part. Fairly nice. And if I backplot this toolpath, and I live by backplot because it's quick and fast. There's my tool going all the way around. And all of you think, what is he doing? His tool shanks out and crashes into the part. Yes, I agree with that. That the tool path is not what I would want to cut, but all I'm really concerned about is what's happening at the tip of the tool, and do I like this motion? It's a fairly smooth motion, fairly consistent all the way down the part, and it looks really good. I don't have a lot of jumps and a lot of retracts out of the part, so I'm really satisfied with the motion of the tool path. Now I need to go in and hone the tool path of something that I would really want to cut and really want to machine on my machine. The first thing I want to do is really limit the amount of rotary axes I have on the machine and keep that tool as vertical as possible on the machine when I'm actually machining it. And to be able to do that, I need to control the tool axis, the axis of the tool. I want to say keep that tool as straight as possible, straight up in Z as I would like to be able to machine this part. So I go to tool axis control, and I'm going to say I want to control this fixed to an angle, and I want to say angle to Z, straight up and down. Essentially, this is going to create a 3D toolpath, not a full-blown 5-axis toolpath, but just a 3D toolpath. And if I generate this toolpath, you will see the tool looks really good when it starts off, but then the shaft and the shoulder of the tool will actually violate and touch the sides of the part. Make sure I generate the toolpath. Generates pretty quick because we have some regen files out there. Only one entry and one retract. Really clean toolpath. Still got my section view. We can turn that off for now. And generate in there and watch it go round and round and round. And here is a very, very simple toolpath. Looks good until I get so deep into the part. Now I have problems. Now my shank or shoulder is actually rubbing the part and won't create a good part as I've done. Now I have to worry about collision avoidance. The toolpath still, in my eyes, looks very, very good all the way through the part from beginning to end when I've limited the motion to strictly being a vertical machine. So now I'm going to add some collision control to my toolpath. And we'll let Mastercam to determine what you need to do to get that tilt to work properly. And I say automatically tilt. Either direction, either used a side tilt or a lead lag tilt. And check it against the drive surfaces to make sure that you don't hit anything. I do have clearances down here of how much I'll be able to leave. 10 thousandths is pretty close. But it does create a very, very good toolpath. Generate my toolpath again. And as you can see, each time I add something to this toolpath, it takes a little bit longer to generate. Now I've added some tilt control and my computer has to think. That's why I always start off with motion first, then limit my motion as much as I possibly can, and then worry about collision control later. Those are my 3 steps in creating a 5-axis toolpath in Mastercam. Like the shaded view here, and we can play through the toolpath. I've been using backplot for speed just to see, does the motion look good? Do I like the motion? Do I violate my part? It looks pretty good on the screen, but nothing really replaces true simulation as we simulate the part with our Mastercam simulator. So I go pick a simulation routine. We'll automatically let the software figure out where it needs to associate to the part. And we'll simulate this in true machine sim. Simulator popped up on another screen for me. Scroll it down a little bit. Here's my workpiece. I don't have any stock. I do have a workpiece. I can show it transparent so you can watch the tool and the motion go in there. Oops, and it didn't really align the way I wanted to in the machine. It'll be okay for what it's running though. I'd probably really put 0, 0, 0 smack dab in the center of my rotary table. Mastercam tried to determine where I want it. On new machines today with TCP, it really doesn't matter where I put that part inside the machine. It would automatically simulate, and I could pick up my work offset in the center of the part just like I had it scheduled inside Mastercam. Automatically spinning, rotating that part. And the motion's pretty even in my rotary axis parallel to the X, which is typically the A axis. Pretty even front to back, so I see no reason to tell Mastercam to say, no, I only want to have the tool tilted to the front or tilted to the back. That looks like the A axis rotation is even from side to side as I go down inside this chamber as I cut. As I go down inside this chamber as I cut, I can look at collision control reports. And I did run out of travel at some point in time, probably over-traveled when I started my toolpath, but that's all right. That maybe my tool's too long for this particular machine, and I need to get a machine that has a little more travel or shorten up my holder to be able to actually fit inside here. It's always good to have the machine sim just to see motion. Even if this is not your exact machine, but you have a similar machine to this, it would be very beneficial to have a simulation of the machine just to be able to watch the G-code run. And as I get down towards the bottom of the toolpath, you'll see that over here in my collision report, it'll actually tell me. I'm going to speed it up a little bit here as we go through. Looks really, really cool. And I get down towards the bottom, and it says I've collided the tool into the table. So I would have to do something to put this up on a fixture plate to keep me from running into the table and marring up my top fixture plate. So center it over the hole, make sure that I am up off the table a little bit, put something out of the way so I don't hit that. So that's a great thing to have, is machine simulation, to be able to watch the tool and watch it run. Again, I just used backplot to get to the motion of the correct, to get it close to what I wanted, and then I decided to run it through machine simulation. So this is just an example of how I approach all toolpaths in general, whether it's drill, whether it's contour, multi-axis, 3D toolpath. What do I want the toolpath to do? How the motion or the CNC machine I want to control. And then I worry about what I want the shank to do or how much motion I want to control. And then I worry about my collisions later. So thank you.